now we're going to multiply and divide rational expressions. Same concept, except, and you can even tell they look the same. Now that it looks like you have two fractions side by side with a multiplication symbol. What you have to understand is you just multiplied right across the top. Before we multiply, what you're going to want to do is simplify. And we simplify by doing what we did yesterday, factoring. All right, so we're going to factor everything. X squared plus 2x minus 3. That factors to x plus 3, x minus 1. And then that's over x plus 2. I'm going to put everything in parentheses. Times x is the common factor. Take that out, x plus 2. And then this is x plus 1, x minus 1. All right, so now we can reduce to 1. So I have x plus 2 over x plus 2. You could think of this, by the way, you could think of this as like one big multiplication, one big fraction. One big fraction, because that's how you multiply. So x plus 2's, that's 1, 1, 1. X minus 1's, 1, 1. All right, you kind of disregard the 1's because multiplying by 1 is itself. So x plus 3 times 1 is x plus 3. But we do have an x up here as well. Don't forget about that. So we have x times x plus 3 over x plus 1. And that would be our simplified expression. We can't go any further than that. Now, our restrictions. Well, we have restrictions. X cannot be negative 2. X cannot be negative 2. And 1 and negative 1 because of this over here. So we only have restrictions on those denominators. All right. This one here, y plus 4, y minus 2. Y plus 3. Wait, no, 4. Wow. Y plus 4, y minus 1. And then we have 3y is the common factor. 3y, y plus 1. And then we have 3 times 2 minus y. All right, that's all factored out. So we can see our let's do our restrictions first before we forget. X cannot equal negative 4 because of this guy. Positive 1. And 2 minus 2, so positive 2. All these values would give you 0 in the denominator, therefore they're restrictions. X cannot equal those numbers. Not x, y. Sorry. Hopefully you caught that. Y cannot equal these numbers. All right, so let's get our 1's and our negative 1's. There's a 1 right there. And that's nothing. And we have a negative 1 right here. Y minus 2, 2 minus y. That's a negative 1. And then we have a 3 over 3, which is 1. All right, what's left over? We have a negative 1. That just becomes negative. We have a y, negative y, over y plus 1. Times y plus 1 over y minus 1. Now, don't get fooled in thinking that something reduces here. Y plus 1 is different from y minus 1. They're totally different numbers, so that nothing reduces there, and that would be our final answer simplification there. This example 3 includes something that you should have learned in Algebra 1, but you may not have, a negative exponent. Recall from Algebra 1 that a negative exponent is a reciprocal. So what the negative 1 means is basically to flip this fraction. So we're going to make it, and I'm going to rewrite this. It's going to be 3m plus 6 over 4n minus 12. I'm just rewriting, except it's flipped. That's what the negative 1 exponent does. and then the other one stays the same. N squared minus 2n minus 3 over m squared plus 4m plus 4. And now we're going to factor everything. So I can take a 3 out of here. 3m plus 2. 4n minus 3. This is n minus 3, n plus 1. And this is m plus 2, m plus 2. m plus 2, m plus 2. All right, so what reduces? M plus 2 over m plus 2 reduces to 1. N minus 3 over n minus 3 reduces to 1. And we are left with 3 times n plus 1 over 4 times m plus 2. And that's it. We can't go any further. You want to multiply that out. If you want to distribute the 3 and distribute the 4, you can do that. It's not wrong. It's just unnecessary to do. We do need our restrictions on n and m. Okay, so I can't, let's see, n can't be 3. N cannot equal 3. And m cannot equal negative 2. Because negative 2 plus 2 would give me 0 here. All right? We have another restriction. Because the given, you have to look at the given, and because we flipped it, so you have to look up here, and this 3m plus 6 will give a restriction as well. M cannot be negative 2, but we already have m cannot be negative 2, so we're okay. So we just have 2 restrictions. Now, division is the same as multiplication, but we flip. Remember, keep, switch, flip? You guys have done when you had to do 2/3 divided by 1/4. You would go keep, switch this to multiplication, and flip that one. So that would be 2/3 times 4 over 1. Keep, switch, flip. And that's the process we're going to use, except we have polynomials now. And remember, this means divide. This is a division symbol right here. All right, so we have x plus 2. Let's set it up. X plus 2 over x squared minus 2x minus 3 divided by, but instead of divided by, we're going to say times, and we're going to flip this one. So we flip the second rational expression. Whatever comes after the division symbol, that's what gets flipped. So we're going to flip that one and make it x squared plus 6x plus 5. And then we just follow our multiplication rules like we did for something like this. Like this would have been 8/3, okay? You multiply. So we're gonna simplify here. All right, so I have, let me change colors. I have x plus 2. That can't be factored. We'll leave it the way it is. This is going to be x minus 3, x plus 1. We have x plus 2, x plus 3. That's this right here. That's not right. What am I doing? X plus 5, x plus 1. Mr. Ventry. This is, even I make mistakes sometimes. X plus 5, x plus 1. And we have x minus 3, x plus 2. All right, so what reduces here? We have x plus 1 and x plus 1 reduces. And x plus 2 and x plus 2 reduces. That's 1, that's 1. They'll become 1s. And we're left with x plus 5 on top. And we're left with 2x minus 3's on the bottom. So the way we're going to write that is x minus 3 squared. You could write x minus 3, x minus 3, but that's x minus 3 parentheses squared because there's 2x minus 3's left on the bottom there. And that would be our final answer. Our restrictions, well, let's see, x cannot equal, x can't be 3, x can't be negative 1, x can't be negative 2, and that's because of these here. But then also, don't forget the original the original denominator, any original denominator, is also going to mess us up. So x cannot, and this was originally in the denominator here. See, this was originally a denominator, so we had x plus 5, right? So x cannot be negative 5, and also negative 1, which we already have. So there's a lot of restrictions on x. X can't be 3, negative 1, negative 2, and negative 5. All right, 2 more examples here. Here's a division. Let's just factor. 4 plus 3x, 4 minus 3x, and then 4 times x plus 3. Now, because it's division, we're going to go multiply, and we're going to flip that one. And I'm going to flip at the same time as I multiply. So this goes on top. And it's x plus 2, x plus 3. And this one's here a little uglier, 3x, x. Hopefully we're getting better at these. 4 and 2, I know it's going to be 4 here and 2 here. 4 and 6, and I need a plus 6, and I need a minus 4. Okay, so what am I reducing here? Well, I have an x plus 3, and I have an x plus 3, that's 1. I have an x plus 2 and x plus 2, which is 1. And then I have a 4 minus 3x and a 3x minus 4, and that's negative 1. And that is it. So I am left with negative 4 plus 3x. I'm going to write that down here. Negative, parentheses, 4 plus 3x over 4. What are my restrictions? X cannot equal negative 3, negative 2. This would be 4/3. 4/3, just set this equal to 0, and you get 4/3. And also, you got to look up here because this was flipped. Remember, that was the original denominator. So negative 2 and negative 3, but negative 2 and negative 3, but we already have those, so we're okay. We already have negative 2 and negative 3. So those also are restrictions. There they are. And our last example, a combination of multiplication division. Same process, except you're just going to flip whatever's after the division sign, so that becomes a multiplication. We're going to flip that one. Going to flip this guy right here. All right, so let's just factor this out. X plus 3, x minus 3. You might want to try this one. Pause the video, try this one. X minus 5. Take out an x here. X, 5 minus x. X minus 4x plus 3. And then times, we're going to flip. So it's going to be x minus 4, x minus 4 on top. And the bottom is an x minus 4, just a plain old x minus 4. This x squared minus 8x plus 16 became x minus 4, x minus 4. All right, here we go. We're ready to reduce. Actually, let's do our restrictions real quick. X cannot equal 5. Oh, 0, because you got plain old x. So x cannot equal 0. X cannot be 5. X cannot be 4. And x cannot be negative 3. And when I flipped this, it was all the same factors, so that didn't matter. It's still just 4. So there's all my restrictions. All right, x plus 3, x plus 3, x minus 4, x minus 4, x minus 4, x minus 4, x, that's 1. And then x minus 5, 5 minus x is negative 1. So I have a negative 1 and I have an x minus 3 left. Negative, parentheses, x minus 3 would be my simplest form. And that's it. See you in class tomorrow for some more practice.